Okay, so welcome everybody to this video in the name of God, the most gracious, the most merciful. This video I'm gonna do the question of NSC November 2014 grade 12 examination, question 8, paper 1 physics, right? Question 8. So please follow on your question paper that you have on your phone or on paper. So note the graph for question 8.1.2 is drawn on the graph sheet. Okay, 8.1, a group of learners conducted an experiment to determine the EMF and the internal resistance of a battery. They connect a battery to a rheostat, a variable resistor, a low resistance ammeter, and a high resistance voltmeter as shown in the diagram below. So that's the diagram that they give us. And then they say that the data for the experiment is displayed in the table below. So that is the data that they give us. So they like to give us this in the exams, graphs and tables. So anyway, so the reading on the voltmeter. So as you can see, as the voltmeter increases, the ammeter reading decreases. Okay, and that you can clearly see from 2 to 6 and 0.58 to 0.14. So as the voltmeter increases, the ammeter reading decreases. So we can clearly see that for ourselves, we can realize, we can understand that the voltage and the current are inversely proportional. Okay. Now, on the graph paper that they give you, the voltage is on the y-axis and the current is on the x-axis. The first question is, set one factor which must be kept constant during the experiment. So if you look at Ohm's law, right, you got V is equal to I times R. Here we are identifying the relationship between voltage and current. So if you want to identify the relationship between voltage and current, the resistance must remain the same, or rather, the temperature must remain constant. Temperature must be constant, whose temperature will affect the rheostat. Okay, so temperature must be kept constant in this experiment. Okay, so that's that part. And then so that's the reading on the ammeter and the voltmeter. Right. So now they say draw the graph. Okay, or plot the points and draw the line of best fit. So basically 2 is about here, 2, 4, or rather 1. Let's say 1, 2, 3, 4, 5, 6. Let's say 0 and 2 is about there. And then 2 corresponds with 0.58. So let's say that is about, let's say that's 0.2, 0.4, 0.6. So 2 is with 0.58, about there. 3 is about there. 4 is about 0, about there. 5 is about here, and 6 is about here. It's about here. 0.14. Sorry, 0.14. So you can clearly see that if you draw your line of best fit, your line will look like that. Okay. Okay. So now the next question is, use the graph in question 8.1.2 to calculate the EMF of the battery. Now, if you look at this graph, right, if you extend the graph towards the y-axis over here. Do you see that at this specific point, there's no current? Now, if there's no current flowing in the circuit, this voltmeter over the rheostat is going to read the EMF if there's no current. So this number here on your graph will give you the EMF. Just remember that if you extend your graph upwards, if you have such a graph, if you get such a graph, okay. And my drawing is not accurate, but you would get an answer of about 7. Okay, you would get an answer of about 7. So they will accept answers from 7 to 7,04, and it do look like it's about 7. Okay, so the EMF of our battery is 7 volts. Okay, then they say calculate the internal resistance without using any equation. Okay, now my understanding is that what's my understanding for the internal resistance of this circuit? Okay, so if you look at the gradient of this graph, okay, we know that resistance in general is equal to V over I, right? And if we get the gradient of this graph, gradient is equal to change in y over change in x. So the y-axis is voltage, change in voltage, and the x-axis is current. And V over I is the resistance. So whenever you have a graph like this and they ask you to calculate the internal resistance, always remember, just get the gradient of the graph. That's all. So the gradient of this graph is change in voltage over change in current. We can say change in y over change in x, it doesn't matter. But then you must get yourself basically 2 sets of coordinates. So we can use any 2 sets of coordinates. We can use the 2 and the 6. So we can go, so it's change, so it's 6 minus 2 over 0.14 minus 0.58. And we'll see in your calculator that it will give you an answer of about negative 9. But remember, this gradient is negative 9, but resistance is never negative, so therefore internal resistance is positive 9 ohms. Okay, so the gradient of this graph gives you the internal resistance. Always remember that. Okay, if they ask you the specific question. So I'm going to stop there. So this just is an example of when they give you this is just an example of a graph question in electricity. So that's question 8.1.3, 8.1.1 to 8.1.4.